Okay, and problem number 2, we're looking at methyl isocyanate. So we've got this molecule that I have drawn here, and we're trying to determine the hybridization on the central atoms in this molecule. There are 3 central atoms in this molecule, and by central atoms, what we're talking about are atoms that are bound to several different other atoms. So we've got carbon, nitrogen. So the carbon is bound to 3 hydrogens and a nitrogen. The nitrogen is bound to 2 carbons, and this carbon here is bound to an oxygen and a nitrogen. So these are our so-called central atoms. That's what we're referring to. So it's these 3 that we're determining the hybridization for. We're ignoring the oxygen on the end, so we ignore end atoms as well as the hydrogens. We ignore those end atoms. All right, so the first thing we have to do is figure out the number of electron groups. And the one thing we want to check on actually is making sure everything adheres to the octet rule. So I'll go ahead and draw this in for oxygen, even though it doesn't matter. We're going to have 2 non-bonding pairs of electrons for the oxygen. Carbon is pretty good. Carbon already has 4 bonds, so it's got the octet rule. Nitrogen only has 6 electrons here, so it's going to need a non-bonding pair. And this carbon here is okay. Now, again, remember the central rules here, the basic rules for organic compounds would be that carbon forms 4 bonds with no non-bonding electrons. Nitrogen tends to form 3 bonds with 1 lone pair of electrons. Oxygen tends to form 2 bonds with 2 lone pairs. These are rules that are pretty good for organic compounds. There are very few exceptions to these rules, particularly with regard to carbon. Carbon's just going to want to form 4 bonds, and it's not going to have any non-bonding electrons. And we certainly see that to be the case here in this particular molecule, because the carbon has 4 bonds here, carbon has 4 bonds here, the oxygen has 2 bonds and 2 non-bonding pairs, the nitrogen has 3 bonds and 2 non-bonding pairs. Now, to figure out the hybridization, we need to figure out the number of electron groups. All right, so let's start with the first carbon over here on the left. So we've got 4 groups on that carbon. And we know if we've got 4 groups, we've got a tetrahedral structure. The bond angle is 109.5 degrees. Roughly speaking. And with 4 groups, the hybridization is sp3. What about the nitrogen? The nitrogen has 3 groups. It's got 2 bonding groups and 1 non-bonding group. All right? So 3 groups for the nitrogen. So for the nitrogen, we're going to have sp2. It's going to be trigonal planar with a 120 degree angle. All right? So this angle here is 120 degrees. And actually, the way I've drawn it, it probably would be better to have drawn just to be more representative of what's going on here. I'm going to draw the non-bonding pair of electrons on the other side. And again, that's 120 degrees. So that would be a better way to represent it. So that's a 120 degree bond angle there. And then finally, this last carbon, it's got 2 groups, just like CO2 had 2 groups. And with 2 groups, we've got sp hybridization with a 180 degree angle. All right, and so I've drawn it more or less like it should look. And that is with the tetrahedral structure on the left with a 109.5 degree bond angle, the trigonal planar structure for the nitrogen with a 120 degree bond angle, and the linear structure associated with the carbon with a 180 degree bond angle. So that would be what the molecule would look like.